We are both students from Harmony School of Science High, and today we are both going to talk about Snell's trajectory law. The law of refraction, which is also known as Snell's law, compactly describes what happens to the trajectory of a beam of light as it passes from one medium, such as air, to another, such as glass.
Snell's law, also known as the Snell-Descartes law, the law of refraction, is a formula used to describe the relationship between the angles of incidence and refraction when referring to the light or other waves passing through a boundary between two different isotropic media, such as water, glass, or air. When light travels from one medium to another, it generally bends or refracts. The law of refraction gives us a way of predicting the amount of bend. The law of refraction is also known as Snell's law, named for Willibrord Snell, who discovered it in 1621. Snell's law is used regularly when performing angle beam inspections. Snell's law describes the relationship between the incident and refracted angles of a wave as it moves from one material into another material, which has a different wave velocity. Refraction takes place at the interface due to the different velocities of the acoustic waves within the two materials. Snell's law equates the ratio of material velocities v1 and v2 to the ratio of the signs of incident q1 and refracted q2 angles. The angle of refraction of light ray passing through an interface between two media is a function of the angle of incidence and the refractive indexes of the media, which is measured by the equation shown here, where Theta 1 is the angle of incidence, theta 2 the angle of refraction, V1 the refraction index of medium containing the incidence ray, and V2 the refraction index of medium containing the transmitted ray. In the example shown here, the definitions of the variables used in Snell's law, an incident light beam approaches the interface between two materials at angle theta 1 to the normal. It passes through the interface and is refracted to angle theta 1 to the normal. The first material has an index refraction of n1 and the speed of light in the material is v1. The second material has an index of refraction n2 and the speed of light in the material is v2. During the duration of the project, I kept a journal documenting my experiences. In one of the entry, I described the difficulty it was to sometimes see the laser through the gelatin. However, eventually and finally, I figured out a way to see through it and measure it. Thanks for watching Harmony Schools.